For at least 100,000 years, two species of humans shared this planet, and only one of us made it out. We didn't just outlast them. Some of us are literally carrying Neanderthal DNA inside our bodies right now. That's not a theory. That's confirmed by genomic sequencing published by Nobel Prize-winning scientist Svante Pääbo in 2010. So the real question isn't whether we beat them, it's whether we actually finished the job we think we did. Because the more scientists dig into the evidence, the more the story of their extinction starts to fall apart. They had fire, tools, burial rituals, and possibly language. They weren't the grunting brutes we spent centuries imagining. What really happened between Neanderthals and Homo sapiens is one of the most debated questions in all of human science. And by the end of this, you might not be so sure which species actually won. To understand this story, you have to go back roughly 400,000 years, long before modern humans existed. Neanderthals evolved in Europe and Western Asia, adapting over hundreds of thousands of years to cold, harsh environments. They were stocky, barrel-chested, with thick brow ridges, physically built for survival in Ice Age conditions. Their brains were actually slightly larger on average than ours. That's confirmed by fossil skull measurements. They made tools. The Mousterian tool culture, named after a site in France, shows sophisticated stoneworking techniques. Archaeological sites across Europe show Neanderthals used fire, cooked food, and made clothing from animal hides. Evidence from Shanidar Cave in Iraq, excavated in the 1950s and re-examined in 2020, suggests they buried their dead. Some burial sites show pollen concentrations that hint, though debate continues, at possible flower offerings with the dead. They also produced what appears to be symbolic behavior. Eagle talon jewelry found in Croatia dates to over 130,000 years ago. A 2018 study published in Science confirmed that cave paintings in Spain predate the arrival of modern humans entirely. That means Neanderthals may have created art, real, symbolic art, tens of thousands of years before we showed up. For a species we've historically dismissed as primitive, the archaeological record keeps forcing us to revise that assumption. Homo sapiens, our direct ancestors, evolved in Africa roughly 300,000 years ago, according to fossil evidence from Jebel Irhoud, Morocco. We began migrating out of Africa in waves, with a significant expansion into Europe beginning around 45,000 years ago. And that's when the two species came face to face, and the world got complicated very quickly. For roughly 2,600 to 5,400 years, based on radiocarbon dating studies published in Nature in 2014, both species coexisted in Europe. That's thousands of years of overlap. Not a quick collision, but a long, complex period of contact. During that time, something happened that we now have genetic proof of. They interbred. The Max Planck Institute for Evolutionary Anthropology sequenced the Neanderthal genome in 2010 under Svante Pääbo's team. The finding was groundbreaking. Non-African modern humans carry between 1% and 4% Neanderthal DNA on average. That means, at some point, Homo sapiens and Neanderthals didn't just fight, they formed families together. People of East Asian descent carry slightly higher Neanderthal DNA percentages than European populations, per 2014 genomic studies. And people of African descent carry virtually none, which directly maps onto the migration timeline out of Africa. The interbreeding happened after Homo sapiens left Africa, but before they fully spread. The genetics are a literal map of history. Some of that inherited Neanderthal DNA turned out to be genuinely useful, and some of it wasn't. A 2016 study in Science found Neanderthal DNA variants in modern humans are linked to immune system function and disease resistance. Neanderthal genetic inheritance helped early Homo sapiens adapt to the European environment they were encountering for the first time. But other inherited variants have been associated with increased risk of depression, blood clotting disorders, and even COVID-19 severity. A 2020 study in Nature identified a Neanderthal-inherited gene cluster as a significant risk factor for severe COVID-19 outcomes. So, the legacy of a species that vanished 40,000 years ago is literally still affecting how we respond to modern diseases today. Now, why did Neanderthals disappear? That's where scientists still genuinely disagree, and the debate is ongoing. The most widely accepted view is that multiple factors combined rather than one single cause wiping them out. Hypothesis 1. Competition with Homo sapiens for food and territory put unsustainable pressure on Neanderthal populations. Homo sapiens appear to have had more sophisticated social networks, trading raw materials across greater distances than Neanderthals did. A 2019 study in Nature Human Behavior found Homo sapiens exchange networks spanned hundreds of kilometers, far beyond Neanderthal range. Larger social networks meant better information sharing, more resilience, and faster adaptation to environmental change. Hypothesis 2. Climate change played a major role. Europe experienced dramatic temperature swings between 45,000 and 40,000 years ago. Neanderthals were already adapted to cold, but rapid climate fluctuations may have disrupted their prey animals and food sources. Hypothesis 3. Disease transmission. When two previously isolated populations meet, pathogens the other has no immunity to spread fast. Homo sapiens, arriving from Africa, may have carried diseases that Neanderthal immune systems had never encountered before. Hypothesis 4. Simple demographic pressure. Neanderthal populations were always small and genetically limited compared to expanding Homo sapiens. A 2022 study estimated total Neanderthal population may never have exceeded 70,000 to 100,000 individuals across all of Europe and Asia. With that kind of population fragility, even small disruptions, climate, disease, competition, could cascade quickly into extinction. The last confirmed Neanderthal fossils date to around 40,000 years ago from sites in Gibraltar and the Iberian Peninsula. They held on longest in the far corners of Europe, possibly pushed there by advancing Homo sapiens populations. But extinction may be the wrong word entirely, because part of them didn't disappear. Part of them became us. Paleoanthropologist Chris Stringer of the Natural History Museum, London, describes it as absorption more than pure extinction. The Neanderthal lineage didn't end. It merged, partially, into the lineage that produced every non-African human alive today. So why does any of this actually matter today, beyond being a fascinating ancient history story? Because the Neanderthal DNA we carry is actively shaping human health outcomes right now in measurable, documented ways. Researchers at the Karolinska Institute found Neanderthal-derived variants influence skin and hair characteristics in modern Europeans. The same variants that helped Neanderthals survive cold, dark European winters are still present and still functional in modern populations. A 2021 paper in Current Biology identified Neanderthal-inherited genes linked to the body's circadian rhythm and sleep patterns, which means the Neanderthal adaptation to long, dark European winters may literally be influencing how some modern humans sleep today. On the medical side, the COVID-19 findings were significant enough that they made international headlines across BBC, Nature, and Reuters. The Neanderthal gene cluster on chromosome 3, inherited by roughly 16% of Europeans and 50% of South Asians, doubles COVID-19 severity risk. That's a 40,000-year-old genetic inheritance directly affecting outcomes in a 21st century global pandemic. It also raises a deeper question about how we define evolutionary success, because by the gene survival metric, Neanderthals aren't gone. Their genes are in billions of living humans, expressed, functional, and affecting health outcomes globally every single day. The field of ancient DNA research that Pabo pioneered is still expanding rapidly. New Neanderthal genomes are being sequenced regularly. In 2022, Svante Pääbo was awarded the Nobel Prize in Physiology or Medicine specifically for his discoveries on ancient human genomes. That Nobel Prize is a formal scientific recognition that understanding Neanderthals is directly relevant to understanding living humans today. And with CRISPR gene editing technology now available, some researchers have even begun discussing what Neanderthal gene variants could tell us about future medicine. So let's bring it back to what the science actually confirms, because the picture is genuinely more complex than the textbooks once told us. Neanderthals were not primitive brutes. They had tools, fire, possible art, burial rituals, and brains as large as ours. They coexisted with Homo sapiens for thousands of years, and during that time, the two species interbred and exchanged genes. Those genes are still in us, affecting immune function, sleep patterns, skin characteristics, and responses to modern disease. Their disappearance wasn't a clean defeat. It was a slow, complex process driven by climate, competition, demographics, and possibly disease. And the scientist who proved all of this with genomic evidence, Svante Pääbo, won the highest scientific award on Earth for doing it. The story of Neanderthals isn't just ancient history. It's a story about what it means to be human in the first place. Every assumption we've ever made about intelligence, civilization, and who deserves to survive has been challenged by this evidence. The species we spent centuries calling inferior turned out to be close enough to us that we couldn't stop ourselves from becoming family. So here's the question worth sitting with. If Neanderthal DNA is still shaping human biology today, did they really lose?